What comes to your mind if you hear about work, energy, and power? In physics, the term work has a very specific definition. Work is application of force to move an object over a distance in the direction that the force is applied. The equation of work is W equal to F times with T. Some things that we consider as work are not work. For example, doing homework and carrying a tray at a certain height and moving forward is not work. Why? First, doing homework is not work because objects are not being moved over a distance. Second, when the force applied is perpendicular to the displacement is normal to the direction of the force. For example, when the direction of the angle is 19 degrees. Hence, the work is done when the force exerted on the body and it must move in the direction of the force. Second, the term energy can be defined as the capacity for doing work. It may exist in potential, kinetic, thermal, electrical, and other forms. On the other hand, power is the amount of energy transferred or work done per unit time. The formula to find power is P equal to F times V.
Hi! So now I will explain example that involve work. So let's watch this video first. So while walking, the work done by friction is zero, and this is because there is no energy being transferred between your feet and the ground. So you don't do any work on the ground and the ground doesn't do any work on you. You can also see this from the equation W equal to Fd. At the point of contact between your foot and the ground, there is no motion. So D equal to 0 and W equal to 0. But let's look on the different perspective. In internal work, like work requires a stretch to a sprint, you do work or spend energy while stretching and contracting the leg muscles, and also angle, which is bending your legs. And for the external work, when you move a crate on the horizontal surface, you do work if you have to work against the frictional force. If the frictional force is F and the crate, which is your body, is displaced by D, then work done W by you is W equal to Fd, which is irrespective of the body mass or weight, which factor in friction. F will be larger for heavier bodies.
For the next example, I am doing no work because even though I lift the dumbbell up and down, they will always return to its original position, which means there is no displacement. Based on the definition of work, work is the quantity that relates the force on the object and the displacement of the object. Since there is no displacement, hence no work is done.
Assalamualaikum to doctor and all of my friends. So today I am going to explain to you about one of the example of work, energy and power. So let's watch the video first. So you have watched the video, right? So let me explain it to you. As you can see, I drove the car. So how is it related to work, energy and power? How is it actually the car move? So where did work come from? Okay, let me explain it to you. So the car moved at a constant speed. I drove the car at a constant speed. So the engine of the car, the one that will provide the force to make the car move. So the engine that make all of it. So this engine that will able to provide the necessary force to make the car move. This engine does the work, which is equal to the produced force multiplied by the distance of the car move. It's not a constant number. But the car is in a state of moving, which is the work will increase as the time move on. So where the power come from? Power is the applied force multiplied by the speed of the car. As the car is actually moved at a constant speed, it means the power also produced at a constant. So a powerful engine not only accelerate a car quicker but also to maintain a higher speed in the presence of wind resistance. So this power actually represent the rate which work done, but it also represent the rate at which energy is consumed. So this engine in a vehicle will convert the energy that available in the chemical bonds of gasoline into mechanical work that apply to the wheel, to the road, and ultimately make the car move. So the energy required is equal to the work done on the car by the engine. So that is how engine works to move the car. So there's power, there's energy, there's work. So I think this is the best example I can give that explain the whole chapter. So thank you, and we move to the next one.
Work, power and energy is a very important concept in physics. Force exerted on an object over a distance does work. Work can increase energy and energy can do work. Power is the rate at which work is done. According to work-energy theorem, the work done on an object by a net force equals to the change in kinetic energy of an object. But why is energy so important in our life? Energy is important because it is a basic human need. Energy is necessary for getting up out of bed or even lifting your finger.